Okay, let's talk about the gamma function. So let's start with the factorial. Factorials, right? So it's defined as, oops. Sorry, I lost my pencil. Okay. So factorial is defined as n factorial, n times n minus 1 times the next number, n minus 2, so on and so forth. 3, 2, 1. Right, if we have 5 factorial, that's 5 times 4 times 3 times 2 times 1. But a question in mathematics is, what is half factorial? Right? What is a 3 half factorial? So gamma function can answer this question. Gamma function will give answer. This is the square root of pi. And this is square root of pi divided by 2. Okay, let's see how. So the definition of gamma function is this. So gamma of x, so this is capital gamma of x, is defined, so this is definition. Is defined as integration from 0 to past infinity. The integrand is e to the negative t times t raised by x minus 1, then dt. So we will recognize t is a dummy variable, right? Cutting the t, x-axis infinitesimal units. And the variable x appears as the exponent of t here. And we want the x definition requires x to be positive. But however, because of the properties of gamma function, so x can be extended to all negative numbers as well. So from the definition, we can show gamma 1 equals to 1. Gamma 1 equals to 1. Now, this is the same as 0 factorial equals 1, right? 1 factorial equals to 1. So x equals 1, we just put into the definition. So 1 minus 1 is 0. T raised by 0 is just 1. So the integrand left with e to the negative t. Then we take then we integrate this, right? How to integrate improper integration? We take a limit, use a dummy variable b, right? Let it b run into infinity. So integrate e to the negative t, we get a negative e to the negative t. Then we evaluate at b at 0, then evaluate when b, take a limit when b approaches infinity. So we get 1. So gamma 1 equals 1. And b, another property of gamma function is gamma of x plus 1 equals x times gamma of x. So we see the factorial, right? The factorial characteristics from here. Because you see here, n factorial, we can write as n times n minus 1 factorial. 5 factorial can be written as 5 times 4 factorial, right? Okay, even this one, even this we see 3 over 2 can be written as a half plus 1 factorial, right? So we see that's a half of gamma of half, right? Okay. So B, the proof is 2. Let's see the proof. Let me erase everything. Let's see the proof. Proof of B. Okay, proof of B. Gamma of x plus 1 equals to x gamma of x. So the input now is x plus 1. So t to the x minus 1 now becomes t to the x plus 1 minus 1, which becomes t raised by x. So we have e to the negative t to the x. So we need to integrate it by parts. So let u be t to the x. Then du would be x t to the x minus 1. Let v be negative e to the negative t. Then dv would be negative e to the negative t. Negative and negative become positive. So a positive e to the negative t dt. Then, so this is from an improper integration. Well, I always have to take a limit of that. Then we'll have uv, right? So this is our uv. Then minus vdu, because v is negative, right? Minus negative now become plus. Plus is what? X, then integration of this. Well, what is this? When b goes to infinity, because b goes to infinity. B goes to infinity, this is just the definition of gamma of x. Right? Evaluating uv, that goes to 0. It goes to 0 for x being positive. But this part is just a definition of gamma of x. So we're left with x gamma of x. So little q proof for the second part of B. Let me erase all this. Okay, so we have this gamma function has this property of factorials, right? So factorial characteristic from here. So gamma of 2 equals to gamma of 1 plus 1, which is 1 gamma of 1. Well, gamma of 1 is 1, right? Just 1. Gamma of 3 is gamma of 2 plus 1, which is 2 gamma of 2, which is 2 factorial or 2. Gamma of 4 is gamma of 3 plus 1, which equals 3 gamma of 3, right? Gamma of 3 is 2, or 2 factorial. 2 times 1, 2 factorial is 2 times 1, which is just 2. So 3 gamma of 3, this is 3 times 2, which is 3 factorial, so on and so forth. Right? You may want to try more. So gamma of n plus 1 equals n factorial. Okay, equals n factorial. So like we wrote it before, gamma of, let's see, 4 plus 1. That is a 4 gamma of 4. Right? Gamma of 4 is a 3 factorial. 4 times 3 factorial, that is a 4 factorial. So gamma of 5, right? 4 plus 1 is gamma 5. Gamma 5 is a 4 factorial. Now let's see the interesting part. Let's see the gamma of half. Gamma of half, we'll go back to the definitions. So we want to find out gamma of half. Push into the definition, we have half minus 1 as an exponent of t. Half minus 1 is a negative half. So I have this. So let's substitute, use substitution method. Let's see, let's use square equal to t. Then t raised by negative half, or becomes t raised by negative 1. Then it's easier to integrate. So 2u du will be dt. So we substitute 2 du will be 1 over u dt, or u squared t. So u is the square root of t, dt. Then we can write as e to the negative u square du, right? Then so how do we get from this step to this step? That's a proof ignored from here. The proof is we're going to find the square of gamma half. So which means we want to multiply another integration e to the, but maybe we want to call it negative v squared dv. We want to use different variables. So we multiply those two because gamma half. So this part represents gamma half. This part also represents the gamma half. So we have gamma half times gamma half. Then we have 4, we have a double integration. E to the negative u squared times e to the negative v squared, we can write as a negative u squared plus v squared. Then du dv. So from here, we want to change variables. We want to change to polar coordinates from Cartesian coordinates, right? U equals r cosine theta. V equals r sine theta. And the u squared plus v squared just the radius squared, r squared. Then du dv, the Jacobi equals r du dv. This needs some calculation, but for this one, I just use it as a fact. So this is a transformation, the change of variables from Cartesian to polar coordinates. We just use it as facts. So if we do that here, we get a negative r squared, right? Those become negative r squared. Then du dv becomes r dr d theta. Right. The improper integration, of course, we take a double limit, right? We use dummy variable, same thing. But the good thing is we can integrate. So with this, we can integrate. Then we calculate. So in the end, what do we get? I'm going to skip the calculation. Okay. In the end, we get pi. So square of gamma half equals to pi. Okay, equals to pi. Oh, one more thing is, when we calculate, we want to calculate in the first quadrant. So the theta just goes from 0 to pi over 2. That's how we see pi appeared. Right? Pi appeared. Yeah, that's it. That's a beautiful, so it's a beautiful thing to answer our beginning question. What's half factorial? What's a 3/2 factorial? Stuff like that. All right, that's it. That's the beautiful gamma function.